Welcome back. In this one, we're going to be starting our new unit, which is all about something called ArrayList. We'll do a little bit of coding and look at this little practice worksheet thing before and after dealing with ArrayList. So ArrayList is a data structure. This would be our second data structure that we know, the other being arrays. You're going to see that ArrayList is extremely similar. Right? It's a data structure. It's designed to hold data of the same type in a sequential order, one after the other. Compared to arrays, ArrayList offer two significant benefits. ArrayList automatically grow and shrink as needed. The ArrayList class is going to supply several methods that handle common tasks such as insertion and removal of elements. Now, I'm going to level with you. You're going to be very happy with me that I am introducing you to ArrayList. You are also going to be very mad at me that I've basically showed you arrays and have waited this long to show you ArrayList. But here is the fact of the matter. I have a whole group of slides and perhaps a whole video talking about why arrays are still useful and why you use it. But here is the actual fact of the matter. ArrayList is just an object that is maintaining an array. That is, it uses as an instance variable an array. So all this is doing is managing an array before you behind the scenes. So whenever I'm saying it's automatically growing and shrinking, it's automatically handling that growing and shrinking of the array instance variable that's inside of it. Okay, so don't be too upset with me. That's really what's going on here. The ArrayList class is not part of the default Java library, and thus we're going to have to import it. So our import statement is coming out of the util class. It's java.util ArrayList, capital A, capital L, that does matter. After the ArrayList has been imported, the ArrayList class I should say, we can create an ArrayList object. Here's our syntax. We're going to use ArrayList, and then we got greater than, less than symbols. We call them angle brackets in this context. Okay, in there is going to be some type of data type. We're then going to basically name the ArrayList. It's going to be our variable. And then on the right-hand side, you see we have a call to new. So we're creating a new ArrayList of that exact same type. This is a call to a constructor. So you see the parentheses there. Okay, these angle brackets are new and different, and I really won't dive too much into them. It's something called generics, which I don't even think I learned in college. I don't even know if it existed when I was in college. It is well outside the scope of this class, but for us, it's not that different from an array. Okay, let's take a look at this construction syntax. The right-hand side is the actual object. This is the data structure over here, right? We're going to construct a new ArrayList object capable of storing strings. The left-hand side of our construction statement is the variable. I'm creating this variable called Avengers, and the data type is ArrayList of string, meaning that this variable can point at or reference an object of the same data type. So compared to our array construction statement, this is basically the same thing, right? Our ArrayList is able to store strings, so is this string array. So this is basically the same thing. Although you'll notice one key difference. There's no declaration of length. Okay, that's because the length of an array is dynamic. It'll automatically increase or decrease as elements are inserted or removed from the array list. And it's actually not called length whenever we're talking about an array list. It's called size. This is going to be one of those little annoying hiccups. It doesn't matter too much because if you see, like if you're in the AP exam, you're either going to have a multiple choice question where it doesn't matter because they'll just have the word size written out. Or if we end up doing FRQs, you do an FRQ, they don't really care about the distinction, right? You could write size, you could write length, as long as it's very clear that you're talking about the number of elements in the data structure, you're okay. So this is kind of an annoying distinction. And let me tell you, the reason it's called size is because, yet again, the array list is managing an array for you, okay? What really happens is the size is just the portion of that array that's in use. meaning you're actually going to have an array that's a little bit bigger than what you need. And you're actually just working in a small portion of that array. And that is effectively the array list. That is the size. So that is why there is a distinction that exists. In the grand scheme of things, it's not super important, right? We got IntelliJ. It'll tell you if you mess up and use the wrong thing, because what I'm getting at is you have a size method, not a length. It's the same thing. Okay, for us, it's the same thing. Size is basically the same thing as the length of an array. But again, notice that at declaration, you don't have to specify anything. That's okay, because as you insert elements, the size will increase. It'll get bigger and bigger and bigger. We see with this example, we have constructed an array list, and then we ask what is the size of it, to which we would get back a 0. This would return a 0. There's no elements in it. Okay, so how do we get stuff in there? The add method. Right, this add method is going to take in an object, and it returns a boolean. Don't worry too much about that. We'll talk about that later. And we're going to append elements. Append specifically means to the end, right? We're adding to the end. So we can see in this example, we construct our array list called Avengers. I take Avengers and I add Ant-Man. The contents of it is just Ant-Man at that point. If I take Avengers and then add Thor, well, we're going to tack on Thor. We're going to append Thor to the end of this array list. If I were to then ask for my size, well, it's changed. There's elements in there now, right? The size is exactly 2. Let's play with that. I got IntelliJ up. We're going to code ArrayList intro here. So let's make a new project by going to File, New Project. There's no real end goal. We're just kind of playing around with an array list. I need to switch to my CSA folder real fast. And then I'm going to make the project ArrayList intro. I'm going to ensure that I have a subfolder. That is a link to a Google Doc. I'm going to ensure that I have a subfolder and that we can kind of play around with this. I'm going to right click on my SRC, make a new Java class. I'm just going to call it driver. We're going to plug in a main method with PSVM. Okay, and I want to make an array list. Now, it's important to note that it is not part of the default Java library, which means we would need to import. Now, with IntelliJ, we can IntelliSense it, right? So I'm going to start to type out array list, and you see that it is sensing some stuff here. And our first option is array list, and it shows us java.util. Yeah, that's what we want. So if I just double click on that or hit enter, it'll import for us. This is coming out of the util class or folder or something. So let's create an array list, and I want to do like an array list of string. How about dog breeds? Now, Avengers is like really my go-to, and it's everywhere. It's in these slides, it's in the before and after that we're about to do. So I'm going to do something different. I'm going to go with dog breeds. So the left-hand side over here, I'm actually declaring a variable. The variable is dog breeds. The data type of the variable is array list, I would say, of string. That is going to point to a new array list of the exact same data type, and this is a call to the constructor, so I'm going to use some parentheses here. Okay, if I were to print off the size right now, we're going to get a 0. So I'm going to right click in free space, tell my driver to run, and you see no syntax errors. There's just nothing in there. The size of this is 0 initially. Okay, well, let's add some things to it. So I'm going to take dog breeds and I'm going to add, how about husky? I'm going to maybe add a beagle. I can then print off the size of my array list, and we'll see that that has dynamically changed. This is sweet, right? This is think about what you would need to do if you're working with an array to basically produce this exact same thing, and how quick it was for me to whip this up. All right, where we're really going to see benefits is like removing elements. So let's figure out how to do that. Like arrays, the elements in an array list can be accessed via their index with indices beginning at 0. Okay, with arrays we have this square bracket notation in order to actually access an element. Here, it's a method, right? The get method can be used to access the element at a specific index. So we're going to call get, we'll provide it with an integer, an index. It's going to give us back the object at that index. In the case of my Avengers array list, we add Ant-Man, and notice that we are getting 0, the element index 0. So just like arrays, this is a good thing. These indices start at 0. If it was different from arrays, that would just drive us crazy for sure. Okay, so back in my example, array list intro, now that we've added some dogs here, right, and we've seen our size, if I do an s out on dog breeds.get 0. Right, again, notice no syntax errors, and I run this thing, and we're going to get exactly what you expect, Husky. Note that an index out of bounds exception will occur if you attempt to access an index that does not exist. In my example, we add Ant-Man to Avengers and then try to get index 1. Well, simply put, that doesn't exist. If I try this here, right, if I try to get maybe the element at index 2, you'll see that we get an index out of bounds. A couple of notes here. Right, it's actually telling me, you know, ArrayList.get. That matters whenever you're trying to figure, like you're debugging, you're trying to figure out an issue. Let's say that you're using arrays and ArrayList in your program. This could, you know, kind of maybe help you dissect it. Also, take a look at this. Index 2 is out of bounds, so it's actually telling you the index that you are trying to access. Now, you may be thinking, oh, that's obvious. There's a 2 on your screen, but consider a loop. Right? Consider you're looping through the array list trying to access elements. Then you can very easily see the index that is causing you problems. Likewise, if we try to access a negative index, same thing, right? This is an issue with arrays. It's an issue with array list. So array list indices can be used when adding or removing an element from an array list. Here we see add. Well, we just had an add. So add is overloaded. This version takes in an integer as well as an object. A reminder that the add that we just saw only took in an object. Right? The add that we know so far takes in just an object and it tacks it on to the end. Okay? This particular add takes in an int. That's an index on where you want to add it. Okay? Take a look at this example. We have our array list, Avengers. We add Ant-Man, so that's all that's in there. We add Hulk, that's all that's in there. I then add, using the overloaded version, a different version where I provide an index. I want to add Thor at index 1 to Avengers. Okay, this is the current state before we add. We have Ant-Man and Hulk. Hulk is at index 1. Take a look at what happens. Thor gets added at that position, and importantly, Hulk is pushed. Notice we're not overriding, we're adding. Let's try this with our dog breeds. We're gonna let's go back to maybe just getting our Husky. I'll play with that one actually. So I'm going to take dog breeds and we're going to add, we'll do the same thing, at index 1, a different B. How about Chow Chow? I may be spelling that wrong and it's okay. All right. Now, here's what's interesting. Think about this. You know, at this point, we have Husky in our array list. At this point, we have Husky Beagle. At this point, this is the current state of my array list, right? This is index 0. This is index 1. So I want to add at index 1 chow chow. So our array list should look like husky, chow chow, beagle after this happens. Okay, I can try getting the element at index 1, and it should be chow chow at this point, so we just added it on the previous line. And let's check that out. Okay, so note that this version of add can be used to append an element to the end of the array list without causing an index out of bounds exception. Here is something that's a little bit weird. I have Avengers, we've added Ant-Man, we've added Hulk. I'm then going to, just for clarity, trying to clean this up, this could be reduced to just one line, but I'm going to pull the size out of Avengers. At this point, size is 2, right? I have 2 elements in there. My size is 2. I'm going to add Thor at index 2, right? 0, 1, 2 doesn't exist. If I tried to do this with an array, this would give you a problem, okay? I'm showing you this because it's kind of an exception, and honestly, this is like test question. You'll see AP exam questions related to this where they try to basically add to the end using this index. And again, if this was an array, it's an index out of bounds. With the array list, it just handles it. Okay, it just handles it, right? This is the exact same thing as the normal version of add, the one that doesn't take an integer index, and you just need to be ready for it. I'll show that here. Okay, let's do dogbreeds.add. Give me a dog breed.
Dachshund.
Give me a dog breed I can spell.
Husky.
I've already got a husky. All right, so let's add, and again, I told you that this could be reduced to just one line. I'll show that right here. We're going to add to dog breeds, at dogbreeds.size.
Bloodhound.
Thank you. We'll add a bloodhound. Is that one word or 2 words?
1.
In our world, it is 1. Okay, so I'm going to add to dog breeds at size a bloodhound. Again, if this was an array, trying to add something at length, right? Trying to add something at length, that would just be out of bounds. But as we're going to see, right, I could just run this, and you notice there's no syntax error. It wouldn't be a syntax error. It would, in theory, be an exception, an index out of bounds exception, and it's just not a problem. If I come in and try to access the element at size, that would be out of bounds, right? So where is this element that I just added? Well, it's at size minus 1, right? It's the last element. It's the same thing as this version of add. I'm just providing the index, and you notice that there's no problem with that, right? Line 14 is the same thing as just using this version of add. We appended it to the end. Again, that's just a test question. You got to be ready for it. Okay, what about the removal of elements? We have seen that array list, adding an element, super easy. It inserts it and pushes the other things. It's very dynamic. We're going to see the same thing with removing. You can remove the element at a specified index, and it will update the array list accordingly. So with remove, I'm going to specify just an integer. Interesting enough, it's going to give me back an object. I want you to think about what that may be. Okay, so here we see our example. We're starting out with nothing. We're adding Ant-Man and Thor and Hulk. So this is the current state of my array list. When I get down to this remove method, we're going to remove 1. Well, 0, 1, that's Thor. So notice that Thor gets deleted, but not only does Thor get deleted, Hulk is going to shift over and close up that gap. That is awesome. Think about that for an array, right? If you delete something from an array, especially an object array, this would just be null. You would have like an empty space there. You would have to, in order to make the length size appropriately, you'd have to create a new array that is 1 smaller and then transfer elements over. It's being handled for you with the array list. Again, this is just managing an array that you don't see, an array that's under the hood, an array instance variable. Let's try this remove. So I've got, at this point, an array list that has a bloodhound in it. which is not an actual breed, but we're going to let it slide.
Great game.
Great Dane would have been good about 3 minutes ago. All right. Oh, what is happening? A little OCD with my stuff here. That's fine. All right. So this is the current state of our array list, right? I want to remove an element. Maybe I should kind of break this up, right? We added stuff. We saw our size. Okay. Let's remove one of these breeds. How about Chow Chow? So I'm going to take my dog breeds and we're going to remove the element at index 1. Okay. In order to kind of see this change, I'm going to do an S out on dogbreeds.get1. All right, keep in mind that this was Chow Chow, but what's going to happen whenever we remove the element at index 1? Chow Chow is going to get deleted. And these other elements, including Beagle, including Bloodhound, are going to shift over and close that up. So the new element at index 1 should be Beagle, right? So once I remove here, this should be the new state of our object. So getting the element at 1 should now be Beagle. Hey, that's pretty cool. Note that remove returns an object. Right? I talked about this. I kind of hovered over it and I said, what is that? Take a look at our example. We have Ant-Man, Thor, Hulk. I then remove the element in index 1. That's Thor. That gets removed. Right? These elements should shift over. Right? Hulk should shift over and close up that gap. But what's interesting is the remove method returns the object that was removed. That could be useful. Maybe you want to actually see what did we in fact delete from that. You know, imagine that you have a loop and you're not exactly sure what elements you're removing as you're going. And so this provides a way to actually see what you're removing by doing that. Of note, you don't have to do anything with this, right? In this example, I'm saving in and I'm printing it out, but remove does the removal regardless of if you print off what was removed, right? That's what's happening here in our ArrayList intro. This successfully removed Chow Chow, right? Technically, what I have highlighted is a string. We removed Chow Chow, and that's just sitting here. I'm not particularly doing anything with it, but if we were to bring in a S out, and I'm going to print dogbreeds.remove 1, what we're going to see is that Chow Chow gets printed here because it is the thing that we are removing. That's actually useful. It's kind of cool. Okay. So I think the last method we're going to talk about here in our intro slides is a toString method. I've been using the get method to actually kind of visualize changes, but here's the thing. There's a toString. Look at this. I have an empty array list. We add Ant-Man, Thor, and Hulk, and then print the array list. If this was an array, we would get some type of hexadecimal reference. But this gives us a toString. We can actually see the contents of our array. I'm going to print off the final thing by just simply saying S out on dog breeds. And we should see this because that was the final state of our array list. And there it is. Again, if this was an array, you wouldn't get that, right? We had to write the toString. You had to loop through and basically make a string with all the elements or print the elements off. It's right here. This makes it so easy to see what the contents of your array list are. So these are the methods that we've learned in these slides, right? We got two versions of add. One where we just provide the object and it gets tacked onto the end. We got this version where you can actually insert the object at a specific index. We have a get method, which is how we access it. It's the same thing as those square brackets from arrays. We can remove an element. Arrays just literally doesn't have that. It doesn't really have an add. And size is basically our length. And of course we have a toString, which makes seeing contents super easy. So if you want to see everything that ArrayList can do, you can always just Google the ArrayList API. Just kind of a method summary is ultimately what you're looking for, and we're going to learn more methods, by the way. These are just kind of the intro stuff that you really need to get started, but there's more stuff here. We actually learned a good bit of this because it's all pretty useful to us. But for now, let's practice before and after array list. You can find this sheet exactly on Canvas, but there's actually a link here in the slides, so if you're just looking in the slides, you can also get to it there. Let's take a look at this little activity that I made. So it says, use the following array list methods to complete the before and after tables below. Note that some tables will require multiple method calls in order to produce the after array list. So just these three methods cause side effects. They cause changes to the implicit parameter, right? Out of all the methods that we learned add, we learned remove. Those are, I should say, maybe mutators. These are mutator methods, right? They cause a change to the implicit parameter, the array list. Get, size, and toString, those are getters, right? They're accessors. They're just giving me back information. They do not modify the object. So when looking at this, that's why I've chosen these three methods. It's not completely random, right? These are the ones that are actually going to make changes, going to mutate our objects. So we're going to assume that we have an Avengers array list for strings. And here's an example. We're going to see the array list in its before state. We're going to see the array list in the after state. And the question is, you can see on the rest of these tables, what do you need to do in order to take it from the before state to the after state? In this particular example, all we did was take Avengers, right? That's the array list that we're working with, and add Hawkeye. That's how we got that tacked on to the end. Okay. So now might be a good time to pause if you want to try this on your own, but I'm going to work through the examples. Here's my before array list, and ultimately the change is we see Thor here at the end. Okay, that's not too bad. We're just going to take Avengers, and we're going to add Thor. This version of add appends it to the end, just like so. Now, note that another possible solution is what I kind of told you with this overloaded version of add, where we specify an integer index, right? Currently, we got 0, 1, 2. I could add at index 3 Thor. Again, that's not out of bounds, and you could have test questions related to this, so I would be prepared. Taking a look at number 2, we see Hulk, Captain America, Iron Man, and in our after table, there's no more Captain America. Okay, looking at my possible options, we have a remove. Remove takes in an integer, that's the index. So I'm going to take my array list, which is called Avengers, and we're going to remove whatever is at index 1. That's Captain America, and that's going to delete that element and cause Iron Man to shift over and close up that gap. It'll look like this afterwards. With number 3, well, this is interesting. I see Hulk, Captain America, Iron Man, and we have essentially replaced Captain America with Black Panther. Okay, of note, it says method calls with an S. Based on what we know so far, we'll learn more, and there's a method to do this directly, but based on what we know, we're going to have to use a combination in order to achieve that. First thing I'm going to do is maybe remove, or you could add. Either actually works here. I'm going to take Avengers, and let's remove the element at index 1. Okay, that's going to get rid of Captain America, and Iron Man will shift over to close up that gap. So this is the state of my array list at this point, once I remove. Okay, well, I need to insert Black Panther. So let's do that. I'm going to do Avengers.add. Again, this is our current state. I want to add at index 1 Black Panther. Sweet. And that should do it. I'm going to set this back, but okay. Here we see Hulk, Captain America, Iron Man. And the difference is I have Ant-Man here. That's it. That shouldn't be too bad. We take Avengers, and we're going to add at index 0, 1, 2, Ant-Man. This game's easy. All right, we see Hulk, Captain America, Iron Man. And when, at the end result, we see Wasp has snuck its way into the beginning. So I'm going to take Avengers, and we will add at index 0 in this case, right? That's what Hulk is right here at index 0. We're going to add Wasp. Notice I'm putting this stuff in quotes, by the way. These are strings at the end of the day. We're going to put Wasp here, and it's going to cause every element to shift over by 1 in order to kind of make room for it. Last one, we see Hulk, Iron Man, Wasp, Ant-Man. Let's see, Iron Man, Wasp, Hulk, Ant-Man. What's changing here? Ultimately, Hulk is ending up in this spot, and Iron Man is ending up in this spot. Oh boy. I'm going to take Avengers. How are we going to do this? Let's see, what did I do here? So Hulk needs to end up here. But we also need to basically delete it. Okay, so 0, 1, 2. I need Hulk after that. Let's first add a Hulk at 0, 1, 2. Okay, what that's going to do is take me to this state. So you'll notice I basically have an extra Hulk, so I need to remove that bad boy. We can remove the element at index 0, which should delete Hulk, and again cause everything else to shift over, and you see there is our final state. Okay, this one gets a little bit interesting because there's other ways we could do it. You know, we could have removed Hulk first. I could remove the element at index 0, which is going to make my array list look like this. I could then add at index, keep in mind, right, stuff is shifted over. This is where things get tricky. 0, 1, I'm going to add at index 1, Hulk. Okay, now here is the big brain play. Note that this is at this point. Here's the big brain play of what we could have done. A reminder that remove returns the object that's removed, meaning what I have highlighted is Hulk. All right, let's back this up. Here's the initial state of my array list. I'm going to remove the element at index 0. That is Hulk. It's going to get deleted. Stuff's going to shift over. But this is Hulk. It is Hulk. It is. It's Hulk. That's what I removed, right? I ultimately want to add Hulk back at a different spot. We can actually combine those two things. I can say Avengers.add 0, 1, 2 Hulk.remove 0. Okay, I'm going to throw this into IntelliJ and we'll go ahead and test it out. But this gets a little weird, right? Because I want to add at index 2, 0, 1, 2, the element that I am removing, which is going to be Hulk. This will actually happen first, which means that this is the current state when I go to add. I'm kind of theorizing here. I'm going to plug in IntelliJ. So 0, 1, maybe this should be a 1 or 2. Let's figure it out. I'm going to hop over to my array list intro. And I'll tell you what, I'm going to make the array list real fast. We're going to take Avengers. We're going to add Hulk. We're going to take Avengers and we're going to add Iron Man. I'm going to add Wasp. And we'll add Ant-Man. This is the initial state. Okay, in order to see this thing, keep in mind we have a toString. I'm going to print that off. And all this other stuff, I'm just going to comment it out so that we don't really have to pay attention to it. Let's see the initial state. I am then going to take Avengers, and I want to add, I think it's going to be index 1, Avengers.remove 0. And then we'll see. Ooh, it was 2. Interesting. Okay, so here it is in the before state. We're going to remove from index 0 Hulk. So once that remove happens, this should in theory be the state of my object, and we'll add to index 2 Hulk. You can see from my confusion, this can be kind of hard to keep track of, right? This dynamic sizing. And so while ArrayList has dynamic sizing and people love it, it can be tricky. That's going to be it for our intro to ArrayList. I'll see you in the next one.